Hi. My name is Mike Goelzer. So yeah, as mentioned, I lead Protocol Labs efforts in libp2p, which is the subject I'm going to talk about. If you're not familiar with libp2p, I'll give you one intro slide, and then the rest of this talk is going to be kind of a project status update sort of thing. My sense is that the people who showed up on day 3 for a talk like this are probably already fairly familiar with libp2p. And just if you have not heard of Protocol Labs, we're a research, development, and commercialization company in nowhere. We have no central location. We're globally dispersed. And libp2p is a project that came out of Protocol Labs, but we don't control it. It's an open source project. It's MIT licensed, MIT and Apache 2, and I think that historically we have been the largest financial supporter of libp2p, although I imagine this year Ethereum Foundation might edge us out on that. But so that's kind of the background. And let me see here. Okay, so this is the one slide where I'll tell you what libp2p is if you're new or don't know. It's a modular peer-to-peer networking stack. Oops. There's supposed to be an animation. There. It is a modular, extensible, pluggable peer-to-peer networking stack. It has a small core. It's implemented in multiple languages, the same core. And then you can build on top of it. You can build whatever your DApp dream is on top of libp2p. And a number of people are doing that. Okay, so I promised you a project update doc. This is my outline. Basically, here's what I'm going to try to cover. First, I want to talk about the growth of libp2p. I did this from the perspective of compared to Web3 last year, which is about like 9 months ago or something. Don't worry if you weren't here, but that's kind of what I'm going for. What has changed since then? And so growth is like libp2p is just like taken off, and growth is probably the biggest thing. Next, I want to talk about new features. Then I'm going to do a little thing that I call State of the Languages, which will be just explaining the different language implementations and what their status is. And then I want to talk about what's coming next, like what's coming down the pike, and where we need community help. I am not going to take questions here because I will run out of time. So what I've done is I've signed up the P2P hackerspace node for I think it's 12 to 1. So come by there with your questions. I'll actually just go right over there. But come by there with your questions, and we will have interesting. We'll have a great time talking about libp2p. There's a couple of engineers here who are familiar with libp2p who I think will join us, and so it should be a good time over there. And if you have even more questions, don't worry, we'll find a way to get them addressed. So 2019 was the year that interest in libp2p basically kind of exploded. And we had been on a steady upward trajectory. This is a graph of GitHub contributions. It runs through, I think, like the first quarter of 19 or something. But basically, we had always been on a steady kind of upward trajectory. But what has changed most since last Web3 is that when I came out here last year, I told you all, the audience of last year, that we had three main language implementations: JavaScript, Go, and Rust. They were interoperable. It was Miracle. That all sounded great. Now we've gone from 3 to 7. So I'll talk in a little bit more detail about each of these. But basically, there's been a proliferation of languages, and it may even continue. So now you ask, why has there been this proliferation of languages? Why are there so many libp2ps implemented in different languages? And the answer is Ethereum 2.0. We are the networking layer, or we are part of the spec for the networking layer. We meaning libp2p. For the Ethereum 2.0 project. And if you came to the Ethereum panel on Monday, they talked a lot about the need to have clients implemented in different languages. The idea being that if there's a bug in one ETH2 client, it won't take down the whole network, compared with Geth in Ethereum 1.0. So this was sort of the motivation. But what it meant in practice was every sort of major programming languages and even some minor ones needed their own libp2p like native implementation. So okay, we did that, and that was probably the biggest effect that ETH2 has had on us. I'll talk more about the languages in a minute. Another thing, ETH2 generally has been like a great forcing function for this project. Like all the things that we wanted to do anyway, we found an excuse to do them because of ETH2's requirements and time frame, which is pretty accelerated. So in addition to the proliferation of languages, we've done a lot of work on improving the specifications. You know, obviously, if you're a language implementer, you want to what you want is a document that says here are the specs for the language, and then you implement. So here are the specs for libp2p, and then you implement that in your language. We've done a lot of improvement there. Noise handshakes was another thing that's been on our to-do list for a long time, and it was an ETH2 requirement, so we finally got it. We have it, I think, almost complete in Go. It's like imminent. We're working on it in other languages. And the last thing I'll just say briefly, multi-select 2.0. So if you're a libp2p old-timer, you may know of a protocol we have called multi-stream select. And what multi-stream select does is it is a protocol for negotiating on first contact the correct stream multiplexing protocol. So it is a protocol for negotiating protocols. And so we called it multi-stream 1.0 for a long time. And then we discovered that most people think that means it has something to do with how you open multiple streams, which is a good guess. Unfortunately, it's erroneous. So we went with multi-select 2.0 instead. And from now on, we're going to be calling it multi-select. I just want to zoom in on one of these, the improvement in docs. This is an important one. Sorry, the improvement in specs. This is an important one. Let me see if I have some better slides. Yes, I do. OK, so this is the specs repo now. As I said, well, let me put it this way. At the beginning of this year, we probably had like 30 to 40% of libp2p specified in some English prose of varying quality, but like somehow specified. I think we're now at 70% and much higher quality, and we're trying to get to 100%. So if you go to libp2p/specs and you haven't been there in a while, I think you'll be impressed. Not only did we add more verbiage about the libp2p specification, we also put together like a life cycle process. My partner in crime, Raul, who is probably somewhere here, put together a 2-axis system for designating specification, the maturity of a specification, and whether it's safe to use. So you can click on this table is at the top of any spec. I just picked one at random, but you should be able to click on the links there and learn a little bit more about how we're rating these things. But we're at least trying to give an indication of like what's in draft stage versus what's finalized. Okay, I just want to do one slide on what's new because that's fun. First, we did some big changes in Go. It's not on this slide, but we switched to Go mod as our module control system. We're hoping to reduce the number of repos over time. We also refactored the Go core interfaces, which used to be spread across like, I don't know, a dozen or more repos. And we used Go type aliasing very cleverly to put those interfaces all in one repository, which is called Go libp2p-core, but in a backwards compatible way, so without breaking existing code. Another thing, noise handshakes, I already mentioned this, multi-select 2.0, I already mentioned this. These things are very close to being delivered. TLS 1.3, it's in Go. It's stalled in Rust right now. We're hoping to unblock it. It is not yet in JS, but it will need to be. We're working on that. Bluetooth transport. So our friends at Birdie are building a Bluetooth transport for libp2p, which is really awesome because our dream has always been that libp2p would transcend the current internet, right? So we need protocols that aren't just TCP/IP. We need protocols that are completely, outside the framework of the internet. And that's sort of how you would create community networks, mesh networks, spontaneous networks that might arise in like a stadium or a protest or any public gathering. So this is actually quite significant. Unfortunately, I think it's still closed source. I'm hoping that'll change soon. But we'll finally have a Bluetooth transport, and there are many other ways to send data. Ultrasonic signaling. You could probably build a lot of different systems to transmit data. So what we are hoping is that this will be the first of many transports that are not necessarily internet transports, and that allow us to route blocked internet connections around through something else, like a Bluetooth transport. And then the last thing I'll mention is auto relay. So this is a good feature. Right now, if you're behind a NAT, without auto relay, if you're behind a NAT, just like a home router or whatever, and you don't know how to open ports, then you can't connect to IPFS. You can connect and fetch content, and the same thing for Filecoin, but you can't. You're blocked from receiving traffic, but unless you're a sophisticated person like people in this audience, and you know how to open ports on a router and what your public IP is, and so on and so forth. So for the people who don't know how to do that, we started running relay servers, which would route all of their traffic through the server. It's encrypted traffic, so we don't know what's in it, but it would route all of their traffic through the server and then advertise the server's address as the address of that person, and then other nodes in the libp2p network, whether it's IPFS, Filecoin, Ethereum 2, whatever, other nodes would send data to that relay address, and it would get relayed back to the host. And so this has made it a lot easier for people to just download the software and start running it and not have to have any clue what they're doing. It turns out that relaying all this traffic is extremely expensive, so we're not going to be able to do it in perpetuity. Our thinking is that we're going to use the current auto relay setup as kind of a rendezvous system for establishing direct connections between peers. So this is kind of an evolving technology, but it's something that we finally got out, and we're happy about that. Let me just talk a little bit about the language implementations. As I mentioned, there's 7 of them. And there they are again. So the 3 original ones are the most mature. I think we tend to use Golib2p as the de facto reference implementation. It's not officially, but it's sort of in practice. It's the reference implementation that we point people to when there's ambiguity in the spec and they want to know, okay, how do I make myself compatible? Rust is one of my favorites. It's very mature. It's being used in Polkadot. It's being used in Substrate. And Polkadot, these are production systems it's being used in. It's a mono repo, which I'm a big mono repo fan. It makes it very easy to get started. So I would recommend that one if you are looking for a way to get started. JavaScript, of course, has the bruiser, which should have been browser, and Node.js. So it'll compile for either target, and if you need to do something in a browser, then you should use that. Just really quickly, these are the newer languages. Kotlin is a Java dialect. If you're a Java dev, you know that. It's relatively new. We're still trying to get it to a, we spec'd out like a minimal milestone, and it's still working on reaching that minimal milestone, although it's very close. And then there's a milestone 2, or I think it's like 0 and 1. Anyway, the point is there's another milestone, which is to have a full libp2p, and that work will start soon. C++ is in pretty good shape. I was just talking to the developers. It's a group of guys in Russia. They feel that it's not stable yet, but they've implemented like all the major things. So take your chances with that. They're continuing to work on it. They want to get it to stability. Python is usable today. It's probably the most mature language on this list. They have a chat example that's fully functional, which is always a good sign. And NIM, lastly, this is just right now. So if you don't know what the NIM programming language is, you should look it up. It's actually a pretty cool idea. But anyway, the point is it's a programming language. Right now, they're just wrapping the daemon, or daemon as you prefer, the libp2p long-running service that is written in Go. What they intend to do, though, is write a full native implementation in NIM. But they have not started, as far as I know. OK, what's next? So I just put one slide up here with some of the more exciting things that we're trying to do. A lot of these could use help from community members. This is a community open source project. Like Protocol Labs is not making any money from this. That's not our. We don't aspire to make any money from this, and we don't aspire to control it. So we are really looking for community contributors. Just really quickly, so those new languages are going to reach maturity probably this year, beginning of next. With so many languages, we need a way to do cross-language interop testing. So we've started talking about this thing that we call the TCK, Test Compatibility Kit. There's probably 100 other names you could call it. I mean, it's not that important. But we're trying to find a way to test all of these together. Security audit, we're having NCC, which is a very well-known and very expensive security audit, a firm that is auditing all of the libp2p stack. We have something called Project Phantom Drift, which is never, as far as I know, we've never publicly talked about this, but this is an idea stage project. This is vaporware. It's an idea stage kind of project to build a visualizer for your entire libp2p network and make it easy for community members to add their own like plugins and then visualize different aspects of the network that maybe we didn't think of when we built this. So this is something that's coming down the pike. Scale testing is a big focus right now. We really want to make IPFS. IPFS has hit certain limits that are actually libp2p limits, and so we're trying to build a test framework just for scale. We want to get to 100% specs. We want to improve user documentation. That's still a common complaint, unfortunately. And I already talked about multi-select. OK, where we need community help. So this is going to be my last thing, and then I'll get off the stage. We just set up a repo called libp2p/devgrants. It's basically our bounties repo. So if you go into this, the way that a bounty is created is you open a pull request describing what you want done, and maintainers can add commits or make suggestions or whatever, blah, blah, blah. Then eventually it gets merged. You can see we have maybe like 10 of them merged in there right now. If you go to the issues section, you can see a bunch that are in placeholder status, which means that we need someone to fill in what it is. I think I have a screenshot of this, but yeah, so this is the issues page, and it goes on a lot longer. That's all I'm going to cover in this time. My name is Mike Goelzer, mike@libp2p.io, and I encourage you to reach out to me or anyone on our team. And again, we'll be I don't know where I'm pointing, but wherever the hackerspace node is, The P2P node, that's where we will be answering questions from 12 to 1. So thank you very much.